CITS Pre-Calc section 1.3 is on solving quadratic equations. Now recall that a quadratic equation is of the form ax squared plus bx plus c equals 0. And that's a general form for a quadratic. Back in advanced algebra, we learned that there were 3 basic ways to solve a quadratic equation. Okay, we could factor it, solve it by completing the square, or do the quadratic formula. Okay, now of those, I know most people like the quadratic formula best because it's a nice, easy formula to plug everything into. I will show you in class how to complete the square and derive the quadratic formula, which is a rather important thing in higher mathematics. For most cases, we like to be able to factor. Now with all of these, notice that the general equation is equal to 0. So therefore, if I'm going to solve it by factoring, or by the quadratic formula, or by completing the square, I need to first of all get that equation equal to 0, factor the equation, and then set the factors equal to 0 using that 0 product property. Okay? If I'm going to do it by the quadratic formula, I still need to have it equal to 0 to know what my a, b, and c are. So there's many different ways of solving them. There are shortcuts involved in that. And we did a lot of it in advanced algebra. Matter of fact, it took a whole chapter to learn all the different ways. We're kind of brushing over them, assuming that you remember most of them. And hopefully the assignment will shake out which parts you remember and don't. But I'm going to go through what I consider the easiest way to solve each one of these. And there are other methods. Okay? So first one, number 16. Big thing to look at is it's not equal to 0. So what I have to do, what a lot of people will do wrong here is they'll divide both sides by x plus 4. We can't do that because we will end up losing one of the possible values of that variable. So we have to keep that inside. We need to get everything on one side. So I'm going to FOIL this whole thing out. Get 2x squared plus 8x minus 5x minus 20. And x squared plus 4x minus 2x minus 8. Now I'm going to try and get everything to one side. Okay, so I subtract my x squareds and I get an x squared. Get 8x minus 5x is 3x. This ends up being 2x. So 3x, subtract the 2x, and I get plus x. And negative 20, I add 8 to both sides, is minus 12. Now, usually we try to factor right away if we can. So on this one, it's going to be the factors of 1 times negative 12, which is negative 12 that add up to 1, which are 4 and negative 3. Okay, nice, easy factoring. We get x squared plus 4x minus 3x minus 12 is 0. We factor by grouping. Factor an x out. And factor a negative 3 out. And then have my x plus 4 and x minus 3. Now, since now I have the quadratic on one side in factored form, it's equal to 0. I can set each of these factors equal to 0. And solve out. Now you always want to double check your answers back in the original equation to make sure that all of them are valid solutions. And again, we get answers, but sometimes the answers aren't a valid solution. Okay, this one should work out just fine. Now, if they're in the shape of number 28, notice we have a quantity squared here. Well, since it's already in a squared form, and this is a 2, not a z, I have troubles making my 2's and z's a lot alike. I go back and forth. What I can do is I can use the idea of completing the square, which means if I have a squared term on one side, I can get it alone by subtracting 5 from both sides. I can then take the square root of both sides. A square root and the squared are the opposites. And when I take the square of the other side, I get a positive and negative answer. I then continue to solve for y by subtracting 2 to both sides. And I have my solution. Now you could multiply this all out, get everything to one side, and plug it in the quadratic equation, and you would get the same answer. Okay, it's just a shortcut because it's already in this form that we're used to. Okay, number 38. Number 38, let's solve that by completing the square. Okay, So completing the square, we can go ahead and we're going to get the x squared plus 2x alone. Okay, we're going to separate that. Now this term has to be a positive 1. If it's not, I have to factor a number out. Okay, it's a positive 1, so I'm fine. I then get my add-on term to make this a perfect square. So it's going to look like this when I'm done by doing b over 2. b is 2. 2 over 2 squared, which is 1 squared or 1. Now, what I do, I add 1 inside the brackets. But since it's on the same side of the equal sign, I added 1, I have to do the opposite of that on the outside. So I multiply this number a times that 1, and I do the opposite there. This then becomes a perfect square. Okay? So this will always factor the same way. It'll be x, whatever this middle sign was, and whatever your b over 2 simplified down to. Now, we already have that in terms of the factored form over here, so I can go ahead and solve it. I move the 9 to the other side. We will take our square root. Again, doing the plus or minus. Oops. X equals -1 plus or minus 3. And we'll have our two answers. -1 plus 3 is 2, and -4. Again, just one way to solve it. Unless it specifies which way it wants, you can pick any of these three. And I'm staying away from the quadratic formula just because, I don't know, I kind of want to. But for the fun of it, let's do 43 with the quadratic formula. To do the quadratic formula, I get everything to one side. I then know that my a is 3, my b is -8, and my c is +1. So all values of x are equal to minus b, the opposite of b, which would be +8, plus or minus the square root of b squared, which is 64, minus 4 times 3 times 1, all over 2 times 3. It then just becomes a formula we just have to simplify. minus 12 over 6. That's going to be 52. Now, square root of 52, that's 4 times 13. Oh, should be 2. Square root of 13. And now, I can factor a 2 out of this first part. And simplify that off. So I get x being, oops, I'm out of the frame right there, aren't I? I get x being 4 plus or minus the square root of 13 all over 3. And there are my two values of x. There we go. Get that a little framed up. Now lastly, same type of problem. We have a fraction form. So I'm just going to simplify the fraction first. And you don't have to. You can do fractions in there. It's just a lot harder to work with. So I'm going to simplify it by multiplying by the common denominator. In this case is 4. 2 and 4 simplify to a 2 on top. So that's 2x squared plus 3x minus 1. Now I prefer to think and try and factor when possible. So I look at factors of -2 that add up to 3. There aren't any, so therefore I can't factor. I could go with complete the square, but it might be a little bit uglier. So I'm going to go with the quadratic formula. Nice, easy one to work with. Again, I've got x equals opposite of b. B squared is 9, minus 4 times 2 times -1. Now be careful of that -4 and -1. That's usually where the most mistakes come in. I'm sure you all remember that. So now it becomes 9 plus 8 instead of minus 8. So -3 plus or minus the square root of 17 over 4. Since 17 is a prime number, That is as far as we can go. So section 1.3 is on just solving quadratic equations. Get used to using all methods. Okay, the complete the square will come back a little later in this chapter. We'll get a lot more practice at that, but you want to start working with it just so it's not such a big change as we get through. Okay.